In this section, we are not attempting to teach any specific processes. Instead, we will introduce you to some of the main pieces of equipment, their purpose, and the types of processes associated with heat pumps. The recovery machine helps us recover or extract the refrigerant from the heat pump. We need to do this before starting any work on the refrigerant circuit. For example, if we were going to remove the plate heat exchanger or condenser, one half of that circuit would be full of refrigerant. Therefore, we need to remove the refrigerant in a safe and controlled manner. The recovery machine pulls the refrigerant out from the heat pump and transfers it into a cylinder where it would be safely stored until it is ready to be reintroduced back into the heat pump. A set of scales is used to weigh the refrigerant bottle, allowing us to measure how much refrigerant has been removed from or introduced into a circuit. Vacuum pumps are used to remove air, moisture and other gases or vapours from a system. Without a vacuum pump, these particles can cause inefficient operation and potential corrosion of internal components. Vacuum pumps draw out moisture and other contaminants from the system circuit, measuring these in microns. Used alongside a vacuum pump, a torr gauge measures even the smallest absolute pressures and provides readings on the dehumidification status of a system, i.e., have we drawn out all microns of moisture, oils or foreign gases. They are available in digital and analog equivalents. A manifold gauge is used to check the pressure of refrigerant systems. It is essential for diagnosing whether the system is correctly charged. They also serve checks such as adding refrigerant and detecting refrigerant leaks. These gauges are available in both analog and digital versions. To connect your various pieces of equipment to the heat pump system, suitable hoses are needed that are rated for the correct pressure and type of refrigerant you are working with. To attach the hoses, a variety of fittings are available, including some that make the job much easier with angled steps and quick release. Electronic leak detectors are used to help identify the location of any refrigerant leak. These are used to check joints after any work, trace leak on systems and check hoses and connections during your work processes. Various types of temperature probes and clamps are available, including a single probe to dual clamps. Some gauges have options to connect to apps, enabling you to take single temperature readings or monitor over a period of time. Taking temperatures at different points of the refrigerant circuits can help identify refrigerant issues when used in conjunction with pressure and temperature charts specific to the type of refrigerant being used. These gauges can also be used for other tasks, and many heating engineers may already have them for measuring flow and return temperatures on heating circuits. Nitrogen is used to pressurize a refrigerant circuit for performing pressure tests on refrigerant lines and components before adding any gases. It is inert, meaning it is non-reactive chemically, non-flammable and stable across a range of temperatures. Therefore, it is well suited for pressure testing and is readily available at low cost. Nitrogen is also used during brazing to prevent oxidation. Dry nitrogen is flowed through the tube during brazing to displace oxygen and prevent scale formation. Some of the tools mentioned earlier may be necessary for maintaining heat pumps and replacing components. However, when installing refrigerant lines in split heat pumps or air conditioning systems, these next tools are more commonly used. The copper pipe used for refrigerant lines features a thick wall design with a high pressure rating, different from the types commonly used in plumbing applications. Consequently, the jointing techniques required are different. Some of the specific items we use include an oxyacetylene brazing set, a flaring tool, and a swage tool. That's a quick run through of all the main equipment items. Most diagnostic functions can be completed using temperature probes. Additional equipment is mainly required during the installation or removal of components in the refrigeration circuit.